Oh, what's the problem? Okay. Yes. Just to YouTube. Oh, yes. But trying from autumn. Yes, this one. The 8. Yes, this one stream starting. Yes, and go there to look for that. Yes, OBS. Yes, right in. Look for him, you know. Like, oh, you have to send this file to it. The file to the file to this one. It's already new, I think. Yes. Don't have to worry about it. Right. What's that? Okay. All right. Yes, you have to look for this one, right? First, that would be fine. Yes. Import a new thing and put in slick. Solid liquid. delete. What's the reason why this is not 12th day? It's iCloud Drive. It's 23. Right. Go to the iCloud Drive. iCloud Drive here. Wait. I have to use this one. Yes. Oh, where is that? Where? Here. And then I crawl. Drive back. This one, right? Okay. Let's talk about the we PM. Oh, yes, sir. Yeah, here. Of my iPad 5. I said so. Yes, and you just open. Hotel. This one. What time now? It's 28. You can see this one is so in 604. Today is 1, right? Yes. Yes, and another one. Yeah, right. Back. No, this one. And it should be right here. It's in 605. Yes, yep. That's it. OBS. This is OBS, right? And here you go to the go live. Go live. And let's manage or no. Go live. it's education. It's education, right? It's no problem. Here. You need to go live in stop. This one is just shape very small, right? So small. Yes. Use this in manage exit stream and look at this, right? No, it's not made for heat. It's the right here. Open begin. Oh no, this one too. This one is Streamlabs. Okay. Alright. Yes. I'll have it. Okay. Yes. Good morning. Everybody. Welcome you to SCI33206, right? And yes, we're gonna go ahead immediately. Yes, I hope that you can see everything, right? I'm gonna stop so that the quality here is quite great. Here. Yes, we will talk about the. I hope the sound and so on would work perfectly. Let me check whether the sound is okay or not. Test 1, 2, 3. Test 1, 2, 3. Right. 1, 2, 3. Okay. Yes. เสียงใช้ได้ครับคุณเลือกดูเอานะครับคุณเลือกดูเอาyes alright okay ก็ยังไงล่ะถ้าส่งลิงก์ให้เหรอก็ it's going to be somehow this Firefox. Where is that reason? Firefox. So where is that? Firefox. So please. Firefox. Okay. All right. Right there. Why? Okay. Yes. We talk about the second question, right? In that example, as I can remember properly. We reached almost quite at the end of this chapter, right? We have to practice more, right? In yes, we live at page 126. Okay, 126 in this one too. Right. That's the second case, the second situation, right? When our statue has been completely pulled up, okay, from the water, and now it's stay above the sea level, right? Sea water level. And yes, then they asked us to look for, I don't completely understand what the lecture note may not be sharp, and the lecture note, right? I've had, yeah, it's already 190. Okay. ภาพชัดไหมครับถ้าไม่ชัดก็แจ้งได้นะครับประภาวิทย์มาแล้วคนแรกครับโอเคanybody else โอเค sorry ชัยสินนะครับเพิ่งเห็นนะครับ and some anyone more who wanna attend okay yes that's the oh I didn't share the screen, right? I'm sorry for that. Zoom. We need to share the screen, right? Okay, all right. In yes, right here. Right? Sorry for that. I didn't share the screen. All right. Okay. Yes, the one we will talk is the second situation when the statue is completely out of the water, right? We were trying to pull it up last time, right? And yes, we have got some information, right? The tension in the previous situation, right, which involves the Boeing Force, right, and it's denoted by FV here, right. In for the last case, now the statue, let's draw the free body diagram, right. It's right here, it's a mass M, right, which represents the statue with mass M. And we have a force right here. Let's say it's in blue. Okay, it's the tension in the second situation. And of course there will be mass W, right, which is mg in this scenario. Let's say this is the plus convention. So we will you would see that yes, you would see that I don't understand often. Okay, you would see that T2 will be positive, right? T2 will be positive, and W is gonna be negative, right? It's gonna be negative. So okay, let me look for the YouTube link. And okay, sign in. The and look at the channel, try to send the link to you, right? New like this, and yes, this one, right? To you M604, right? And right here we have another link for M604, right? And this one too, right? Okay, 3 links have been sent to you, right? Okay, yes. Next โอเคประภาวิทย์อยู่ที่อันนี้นะครับมีนักพัฒน์มาครับแล้วก็2 คนดูที่นั่นครับมีประธานินด้วยเข้านะครับมีใครจะเข้าอีกไหมครับที่ซูมนะครับผมจะไม่ค่อยเห็นนะครับ Okay, as we have adopted the upward direction as the positive side, right? So we have 2 things like this, and from the Newton first law, right? Newton first law, we would have sigma f, right, equal 0, and yes, going up is positive, right? So T2 minus W equals 0, right? So we want to find T2, right? So T2 will simply be W, which is mg, right? M is the mass of this one, which is 15 kilogram, right? 15 kilogram, and here times G, which is 9.8. Okay, and from 9.8 you just make the multiplication, right? It's 15 times 9.8 will be 147. All right, you can also use the number 10, right, as the gravitational acceleration, so it's 147 Newton. All right, so now we finish this example, and let's talk about the next stuff in this topic. Okay, that everything is fine, right? Okay, an object is floating like this. Okay, in there are 2 forces, right? And at the equilibrium state, okay, when it just stay in a static form, okay, there is no movement and so on. The 2 forces are equal in magnitude and opposite in direction. So the next one, we consider the floating scenario, right, for an object or in between at the water surface. Okay, some part of them will be sunk, okay, will be submerged into the water. Okay, and yes, you can see that there will be only 2 forces. Okay, there are 2 forces only, in there is nothing more, right? Because we didn't connect this mass to any hoisting cable. Okay, we don't use the hoisting cable at all, so we would have no effect from that. Okay, no lifting force by any other cable, right? So yes, okay, I'm trying to listen to, okay, หงนะครับ sorry. Yes, มีใครจะเข้าอีกไหมครับถ้าจะเข้าก็แจ้งได้ครับ all right, the next thing is okay, let's talk about the detail. An object floating on the surface of fluid is, and it is acted upon by 2 forces, such as gravitational force. Okay, this one, the force that is caused by the gravitational acceleration on Earth, right? And the lifting force is the Boeing Force. Okay, is vector B here. Okay, and let's go further. If VPS is the volume of the object. Okay, what does PS mean? PS stand for partially submerged. Okay, not fully submerged. Okay, we consider the partially submerged case here. And next one is the similar to 75. Okay, the Boeing Force can be where is that? 75 is low FVOT right here. This one, low FVONG right. This one too right. Low F, but and this one, the second variable, which is the volume, right? In is the volume of the object, but in this case, it will be only the volume will be only the partially submerged portion. Okay, the part that is under the water surface. Okay, is denoted by volume with subscript PS. Okay, with subscript PS. The last term, the third term, is the gravitational acceleration. It's the same. Okay, there is nothing changed to this, right? Okay, next we will talk about the equilibrium state, right? Where once we apply the Newton's first law, when it's in a static state, in equilibrium state, both forces will be equal in magnitude, right? In yes, when both are equal to each other, we're gonna use the typical gravitational force, right, of the object. This is the weight, right, which is mg, but m is the mass of the whole piece material here, which seems like a kind of wood, right? In it's mg, it's m, w is m object, right, times c, but mo is the mass, right, from the density definition, rho or d by is m by v, right? So m0 is gonna be rho 0 times v0, right? Yes, and that's the reason why we have on the left hand side rho 0 v0 vo, sorry, v rho o vo and g, right? Because we substitute mo to this side and we get rho o vo and g, right? And on the right hand side, we're gonna have rho f v p s and g, right? We cancel g, okay, on both sides, and we're gonna have rho o vo rho f v p s, okay, partially submerged volume. And the next one is this thing, right? We move the same kind of quantities, okay, to the same side, okay. For example, we have the product of density and volume, right? Density and volume. We move density to another part, okay, to another side, and we'll move the volume term to another side, and we get the ratio of object, density of object by density of fluid, right, is equal to density and volume of partially submerged portion and volume of that object. Okay, you would see that the volume of the partially submerged object partially submerged object here, Vps is less than the volume of the object, right? So rho o is the density of the floating object here, right? In rho f is the density of the the liquid or the fluid here. And of course, you would be able to guess that the density of the floating object is less than the density of the fluid. Okay, because VPS is less than the volume of the object, right? So we can conclude that rho of the object is less than the density of the fluid. It means, okay, if you see anything floating above the water or the fluid or the liquid, right, you would guess that the density of that object would be less than the density of the fluid under that material. Okay, you understand? If you see anything floating, it means the density of that object is less than, okay, the density of the fluid. Okay, now let's move to the next page. Okay, that's only the simple formula, right? Rho O by rho F equal to VPS by VO. Okay, now let's talk about a loft. Okay, what is loft? It's kind of wood. Okay, wood ผมก็เพิ่งทราบว่าเนื้อไม้นี่มันเบากว่าเนื้อน้ำนะครับมันหนาแน่นน้อยกว่านะครับ The density of the wood seems to be less than the density of the water, and we get this situation. Right here, and the whole piece. Okay, let's say we have a perfect cubic shape of this wood. Okay, in it's called a loft. Okay, and someone try to build a raft, and maybe they wanna travel along the canal or the river and or something like that. And let's have a detail. Here is a cubic shape of the loft. Okay, it's a perfect cubic shape. And a loft is constructed of wood having density of 600 kilogram per cubic meter. Okay, and as I told you before, okay, the density of the loft or the wood is less than the density of water actually. Okay, and yes, once you look at these, they say the surface area, okay, which means this side. Okay, this plane, okay, this planar surface is smooth. Okay, its surface area is 5.7 square meter, and its volume is 0.6 cubic meter. So you would be able to determine the total height of this one, right, by dividing this number. Oh no, this is the surface area. Yes, dividing this number 0.6 by 5.7, and you will get a total height. Okay, but it doesn't matter. It matters actually. Okay, when the loft is placed in fresh water, let's say it's a pure water. Okay, we could use the 10 to the 3, right? 10 to the 3 for the density of the fresh water here in figure 57, right? And to what depth h is the bottom of the loft submerged. Okay, they would like to know what is h in this case. Okay, what is h in this scenario? Okay, I hope that it's not too difficult to you, right? It would not be too difficult. And okay, yes, The next thing is what is that? Okay, yes, the next thing is we would go into the detail, right? How to determine it in this scenario. And yes, the principle we have just learned before is this one, right? Low O by low F. Low O by low F is equal to VPS by VO, right? So now let's open the new page. I remove this one, right? Okay. From the formula here, rho O, the density of the object, right? By rho F. Okay. They say they have also provided density of the wood, right? The Loft, which is rho O. We know that it's fresh water. We could use 10 to the 3, right? 1000. And VPS is the surface area, right? Times H. Okay. And VO is the volume of the object, right? Volume is also already provided there. Okay. Let's consider equation 87, right? From we use this one, the blue one. Okay, from equation 87, right? We have rho O by rho F, right, equal to VPS, right, by VO, right? That's VO. Okay, rho O is right here, and yes, the next thing is let's get into detail. Law of the object, the density of the wood, right? Rho O is 600, right? Kilogram per cubic meter, and the next thing is the rho F, right? The density of the fluid, which is the water. Rho of water is 1000. Okay, 1 ton, right? Kilogram per cubic meter. And VPS, okay, VPS is the volume of that of the partially submerged portion. VPS is gonna be the cross-sectional area times H, right? Because right here we have to take into account the volume of the partially submerged portion, which is only A and H. Okay, the cross-sectional area A and H. Okay, the height. Okay, small height, the depth actually. Okay, yes, we get VPS like it, and VO, the volume of the object, right, is 0.6 cubic meter, like that. And the important thing is the area here is already provided there. It's 5.7 square meter, right? Okay, everything is fine right now. We substitute everything into this expression, right? VPS, rho O by rho F equals A and H and VO, right? We're gonna move everything for H, right? So we're gonna have H will be VO, right, by A and times rho O, right, by rho F. Okay, and now let's talk about the numerical computation to this formula. VO, the volume of the object is 0.6 and density of the object is 600, right? And divided by the area, which is 5.7, and density of the fluid, density of the water, actually it's 1000, right? 1000. All right, you get 1000 here. Let me take a look at this. Switch account. Go to this one. Okay. Just substitute it right into the calculator, right? Substitute this into the calculator. What is that? 0.6 ผมใช้อีกจอหนึ่งครับไม่ได้ลงที่ iPad ครับขี้เกียจขยับนะครับโอเคไหม 0.6 times 600 and divided by 5.7 times 100. Oh no, 1000 here, and it's gonna be yes, it's equal to, okay, it's equal to 0.06. okay, it's equal to approximately, okay, 0.063. okay, if you want 157 blah blah blah, okay, and it's in meter, right? In I'm not sure whether it's correct or not. Let's check. Oh yeah, see with 0.06. 0.06 and in meter, right? So yes, you are gonna have if you talk about centimeter, right? It's 6 centimeter right here. Okay, 6.3. okay, approximately. Let's see, right here, approximate 6.3 centimeter. okay, and that's it for this problem. okay, it's not too difficult, right? You just simply use this formula, the ratio between density and the volume. But for this scenario, okay, for only partially submerged situation. Yes, now we move to the next story. The next, this one is quite difficult actually. This one is rather difficult. Okay. มีคนพิมพ์มาด้วยมีใครจะเข้าอยู่ครับผมย้ายไป YouTube นะครับสุภสินตามสบายเลยครับประธานินนะครับโอเคyes สุภสินนะครับตามสบายนะครับ yes สุภสินรู้สึกจะเป็นคนที่ได้100นะครับโอเคไม่รู้นะลายกลุ่มของคุณครูที่โรงเรียนเขาพูดอะไรไบอันนะไบอันสอนวิชาอะไรนะ okay, now we arrive at a difficult situation. okay, when we have 1 times 10 to the 3, right? This is to the 3 kilogram cube of aluminum. okay, we have aluminum here and is placed in a tank. Okay, we have a container which is called tank, and water is then added to the tank like that, and until half the cube is immersed. Okay, only half the cube. Okay, only half this is immersed. And what is the normal force on the cube? Okay, they want to find the force. Okay, pushing this object up. Okay, in tries to move this one. No, just acts. Okay, on to the bottom part of this aluminum cube. Okay, in what is the normal force, right? In this figure, see the left side of figure 58. Okay, this is figure 58. Okay, we have figure 58 in yes, in the second situation, the cube stay like that, and we add the back mercury. Okay, slowly. Okay, we slowly pour mercury. Okay, mercury is a kind of liquid, right? Mercury is a kind of liquid, and we pour it, and there is slowly. Okay, if you pour it quite quickly, it can destroy or disturb this object, right? And from nature, you know that if you can remember the value of the density of the mercury, you would see that the mercury density is in the same scale, in the same order as several heavy metal, right? Yeah, the heavy metal would be in the same scale as the mercury. So yes, of course, the density of the mercury is greater than the density of water. So everything would stay at the bottom, right? Once you pour the mercury will stay at the bottom part of the whole mix of liquid, right? There are two kinds of liquid, water and mercury, but mercury is heavier according to its density, right? It has more density, so it stays at the lower part here, and also it stay under the aluminum cube too, right? And yeah, you know here aluminum cube has the density as same as the density by water. Okay, so it's not so heavy, the aluminum. Okay, and mercury is now slowly poured into the tank until the normal force of the cube goes zero. So now everything is in equilibrium state, and yes, of course, in the first scenario there is still force acting by the bottom of this tank or the container, acting upward, right, to push this material up. And of course, this material had its own weight, right, which is represented by aluminum times the gravitational acceleration vector. And of course, once it's is partially immersed in the water, there would be Boeing Force, right, by Archimedes principle. And in the second scenario, we have another kind of liquid, which is mercury. Of course, there will be the same lifting force or Boeing force by water, because the water doesn't disappear from this situation, and we have another liquid, right? And that liquid is mercury, there should be also lifting force caused by mercury. It's Bhg, and the mass of the weight of this material still stay the same, right? Remains the same. But they consider the critical situation, the situation such that the normal force here doesn't appear anymore. Okay, the normal force just disappear. All right, so you understand completely the whole mechanism in this example, right? So it's time now to the question for the second problem is, the second question here is that how deep is the layer of mercury? How much we should pour the mercury in this container, in the tank, right? So the first one, what is normal force, and the second one is Hg, okay, mercury. What is that? The depth or the height? Okay. โอ้ทำไมมันร้อนจังครับผมน่าจะดื่มน้ำร้อนครับขออนุญาตลดแอร์นิดนึงครับ All right. Yes. The quantities that we have to calculate or determine are those two things, right? The normal force, okay, in Newton, and the height or the depth in meter, right, in the SI scale, right? So just let's get into the first situation, okay? Situation one. Situation number one, right? If you draw the free body diagram of this object, okay, you would have M here of this material, aluminum actually, and here is the weight, right, which is M aluminum times C, right? And there are two forces acting upward, right? The first one is the normal vector. The second one is the Boeing Force, right? It's vector B, right? Here. All right. Yes. From again the Newton's first law. When the objects are in equilibrium state, right? When the objects are in equilibrium state, we have sigma f remain 0, right? And yes, let's say we use a typical convention. Going up is positive, so we have n, right? Oh, sorry for that. I should use the rate for deriving something, right? Okay. Yes, going up is positive, so we would have here n, right, positive, plus b, right, positive, but w is pointing down, so it's negative, remain 0, right? Yes, you would get something like this, and we're gonna move it, right? Yes, our destination is the normal force right here in, right? So we're gonna move these two terms to the right hand side, right? So n will be w minus b, right? Yes, open again. Yes, And as you know, W is mg, right? So let's talk about W equals mg, right? MAL times g. And what they provide is nothing, right? Yeah, they say its mass aluminum is 1000, right? Times g, right? 9.8. So it's 980 Newton. And the Boeing Force, right? Boeing Force is B, right? B is now it's the partially submerged situation, right? It's gonna be low of fluid, right? Low FVPS, right? V partially submerged volume, and G, right? So what they say is until half the cube. Okay, half the cube, it means the volume is half of that, right? So it's the, do they also provide the volume? They didn't provide, right? Okay, no problem. They didn't provide the volume of the aluminum at all, right? I hope that we need to use the density of, yes. I'm sorry for that. This is not density, it's mass, right? So the density of aluminum is greater than the water, okay, greater than the density of water. And yes, they didn't provide the volume of aluminum, right? Volume of aluminum is unknown too in this case. So we have to solve ourselves, okay, for the volume of the aluminum cube here. Okay, let's get back to the formula of the density, right? Density is the mass of that object divided by volume of that object, and we need to find volume of aluminum, right? We need to find volume of the aluminum. So we move V to the left, and we have mass of that aluminum by rho of aluminum, right? And from the table somewhere, if you can remember, I cannot remember the density of aluminum. Where is that? Density of aluminum. Right here, right? Density of aluminum, is there any? Here, right? 2.7 times 10 to the 3, right? 2,700. Any info? Yeah, here. Okay, the same value, 2.7 times 10 to the 3. So now we could use that, and yes, from the table, okay, from the table we get low aluminum as 2,700 kilogram per cubic meter, right? So we would be able right now to determine the volume of aluminum. Volume of aluminum is gonna be, because they say the mass of this aluminum cube as 1,000, right? 1,000. So which one? Okay, this one, right? Aluminum has the mass of 1,000, so it's 1,000 here, right? Divided by 2,700. Let's leave it like that, okay? Because they didn't ask as about the volume at all. So let's go to our target. Because the block of aluminum, the cube of aluminum just stay under the water for only half the whole volume. So we partially submerge it. VPS will be 1/2. Okay, 1/2 of V aluminum of that object. So it's gonna be 500, right, by 2722, right? So simply speaking, it's 5/25, 27, right? It's no, it's cubic meter, right? The volume is cubic meter, and yeah, we get VPS right now. Yes, Boeing Force is Boeing Force would be ready, and yes, we have N, right, W minus B. So let's compute Boeing Force, which is rho F. The density of fluid here, density of fluid, okay, it's water, pure water, it's 1000, right? Low F and partially submerged volume, it's 5/27 times 9.8. okay, ขออนุญาตใช้อีกเครื่องนึงนะครับเพื่อว่าคำนวณให้นะครับ100 in 100 times 5 times 9.8 divided by 27, right? It's 181. Okay, it's approximately 181 times 0.48. Okay, 481 actually. So it's Newton, and yeah, we will be able to find the normal force right here, right? N equals W minus B. N equals W minus B. W is the weight, right? Which is what we have computed. Which is what we have just computed here. It's 980, right? 980 Newton. Oh no, sorry. minus 181, right, 0.48, right? And we're gonna get the results right here. Seven, 8, 9, okay. 7, 8, oh, stupid, my hand. 7, 9, 8. 98.519, okay, Newton, okay, and that's the answer to the first question in this example, in this problem. All right. มีใครอยู่ครับที่นี่ที่ซูมมีชัยสิทธิ์อยู่นะนอกนั้นมาแล้วไปแล้วครับเดี๋ยวเผื่อกลัวไฟดับนะครับขออนุญาตแคปเจอร์หน้าจอนะเพราะว่าใช้เครื่องนี้ทำแล้วมันอาจจะอัดไม่ค่อยดีครับokay, and yes, for this one we are gonna capture the screen, right? We capture the screen and M604, right? M604 right here. Alright, no, this one, no, this one, right? Okay, and this one too, right? And for the PL in zoom, right? PL in zoom. นะครับเพื่อความเซฟนะ folder. Oh, where is the folder? Right here. Oh. เครื่องมันเก่าๆแล้วก็จะช้าหน่อยนะ and look for shortage okay this one okay right this one M604 M604 like this okay yes ถ้าใครไม่ได้ชื่อมีชื่อนะครับก็รีบพิมพ์เสียนะครับโอเคไหมโอเคthe oh no stupid I should not yeah yes it's correct I have to okay we have to solve the second question in this problem okay we arrive at this situation the second situation okay situation 2 right we have completed situation number 1 right the first situation so situation number 2 right so they slowly pour mercury into this container in the tank right and yeah there is no more normal force here but the next thing is the mercury right the Boeing Force caused by mercury right and as you know from the first and the second scenario nothing changed right we didn't have change in water volume we don't have the change of the aluminum mass right so yes aluminum mass it remains the same okay and we have the new thing which is mercury and you get the lifting force caused by mercury here and just when everything remains the same except for the mercury Boeing force okay the Boeing force caused by mercury lifting force by mercury we can if you okay start from the Newton's first law again you would see that from the first and the second situations the lifting force caused by mercury should be equal to the normal force right so simply speaking we would say Boeing force caused by mercury is gonna be the normal force from the first scenario right yeah let's talk about the detail of the Boeing force caused by mercury of course it's partially submerged right so you have here there's the mass of aluminum right aluminum right and you have two layers of liquid right you have two layers of liquid the first layer is water okay let me use the gray one okay this is the level of water เห็นไหมครับผมใช้สีเบาๆอย่างนี้คุณเห็นไหมlet me check okay you still see you are still able to see you could still see all right Yeah, the second layer is a heavy material, right? It's mercury right here. Okay, this is the layer of mercury. This is water, right? And of course the mercury would be also around the piece of aluminum, right? And what they want to know is the depth, right? The height here, okay, height of edge of aluminum, edge of HG, okay, what should it be, right? Yeah, we can look at this problem like this, and once you clearly write down the free body diagram of this one, you would be able to tackle this problem easily. Okay, BHG is from this figure, BHG would be the lifting force, right, caused by mercury. So it's rho F, okay, law of what? Law of mercury. Okay, law of mercury. Law F, VPS, V partially submerged. So volume of the partially submerged portion. So it's, what is that? It's I don't know, PS partially submerged times G, right? G is quite simple. It's 9.8 or 9.81 or number 10, as you like. Okay, and the critical thing is VPS, right? VPS, there's VP partially submerged here. Of course, it's I don't know, it's half of, I don't know, yeah. VPS is the cross-sectional area of the aluminum, right? Of the cube, okay, it's cube, and times H, right? HG, okay, which is what we would like to know. A cube and depth of the mercury. ขออนุญาตตอบนี้หน่อยครับข่าวของที่มหาลัยครับเขาถามว่าจะรับหรือเปล่าลืมเลยนะ Okay, yes, VPS is like that, and once we still don't know A cube, right? A cube, we still don't know A cube, so we have to find A cube. What is that? Yes, A cube, just take a look at cubic shape, right? This one has the depth as, let's say it's what should it be, X, okay, it's X right here, also X here, and also X there, right? It's X, okay. So the volume of cube or aluminum is X to the 3, right? Cubic, right? Power of 3. Okay, but we know earlier that volume of the of aluminum is this one, right? So it's, I don't know, somehow I don't know, 100 divided by 1000 actually. 1000 divided by 2733, right? 0.37. Okay, 0.37. Approximately 37 cubic meter. Okay. Yes. Now we have that. Okay. We cube is actually, this is aluminum, right? we have that number, and we would like find x square, right? What is x square in this scenario? We have x to the 3 as 10 by 27, right? X with the power of 3 equal 10 by 27. And what about x2? Okay, x2 is gonna be 2 by 3, right? So it's 10 by 27 in 2 by 3, right? With the power of 2 by 3. Yes, yes, we would substitute it in to the calculator, right? We use calculator again. 27 with the power of 2 by 3, right? It's 0. So x squared is approximately 0.515,732 blah blah blah. Okay, that's the square meter. This is the area here. Okay, it's the area here. Okay, area equal x to the power 2. Now we know that the a cube is this value, right? So substitute VPS into this expression and move everything for HG. Okay, BF, right? BF on the left, below of HG, right? HG, and this one is VPS is a cube, and h of hg and g, right? The gravitational acceleration on our planet, and yeah, we move every term except for hg to the left, right? We're gonna have hg, right? The height of the Mercury as BF, right? But you know, BF is normal force, right? It's the same thing, so you can simply say it's normal force divided by density of the Mercury. We will talk about that later. The a cube too, right? And the gravitational acceleration on Earth, right? So you get right now n, the normal force, right? โอ้ผมไม่ถนัดเลยผมเปิดใหม่ดีกว่าอันนี้ปิดดีกว่าอันนี้ของห้อง5เปิดของห้อง4คุณดีกว่านะครับ solid liquid 26 right here. Okay, B is okay, V is like right there, one. No, N, right? We want to find N. N is 798.519 divided by open parenthesis the density of the aluminum, right? Oh, density of Mercury. I'm sorry for that. Density of Mercury. Where is that? Oh, ต้องเปิดหาครับ Density of the Mercury. Okay. อยู่ไหนอ่ะนี่ Okay. Density of the Mercury. No. Not this table. Is that right? This is the viscosity here. Okay, density of the Mercury. Where is that Mercury? here. Okay, 13.6 from book number 1, and mercury 13.6. Okay, the same exact value, exactly the same value. So we get back to good notes, right? So row of this one, 13.6 times 10 to the 3, and a cube, the cross-sectional area we have just got recently, and it's 0.51, okay, or 572 is up to you, and G is 9.8. Okay, let's substitute into the calculator. Okay, this one, and what's that? ขออนุญาตเปิด October ในคอมพิวเตอร์นะครับ where is that? This one, October. All right. Here, where is the mouse? Oh, the mouse. Okay.ตัวใหญ่ไปโอเค October here n what is n n โอ้เรามาได้ทำเวลาได้ค่อนข้างดีนะครับโอเคมาn right n n is 980 minus b, which is 100 times 5.27 times 9.8, right? And that's n. Okay, n is something like that. And rho hg, right? Rho hg and a cube. A cube is this number, right? A cube. A cube is this number, and get that right. And yes. And now we compute h of hg, right? Mercury hg will be n divided by 13.6 E3 multiplied by a cube in times 9.8, right? So you're gonna have we have got already, it's 0.01167, and that's in meter, right? It's in meter. In in the centimeter, right, it's equal to 1.17 centimeter, right? Approximate. Okay, approximation 1.17 centimeter. All right, yes. Not sure whether it's correct or not. Let's check the result. ถูกต้องไหมครับ n n ผิดเหรอ โอ้ผิดนะครับ n ผิด n ผิดมาแล้ว oh my god. n is mg 1000 No, it's not one. Yeah. Yeah. 9,000. Right. Yes. B. Mass of B is low fluid 1,002, right? My God. I'm stupid. คำนวณใหม่ครับขออภัยนะครับ B is this one right 1,000 ก็คือคูณ10เข้าไปนะครับให้ it's 7,895 okay this one 14.8 okay and this one too 8 and here too, right? And yes, it's 5.19, right? Okay, 0.2 simply, and yes, right here, we need to have this one above 519, 519, okay. And yes, it's times 10, 0.1, right? So it's 11.7 approximately, 0.7 centimeter. Yes, right here. Okay, 0.1167. Okay, the height of the mercury that we have to pour in. Yes, we finished. We have to stop at 10, right? So 9:50, right? Remaining time is 5 minutes. Okay, we have completed the. We have already completed the fluid pressure and Boeing force already. Okay, if you have any question, just let me know. If not, then we are gonna go ahead with the next topic. Okay, next topic is about the ideal fluid. Okay, we are gonna talk about how it moves, how it flows, and so on. And yes, fluid กสิดิตนะพิมพ์เพิ่มมานะครับthe fluid flow okay can be extremely complex, so it's this is the realistic okay fluid. The fluid flow can be extremely complex as shown by the flow of a river in flood or the swirling flame of a campfire. Okay, if you go to the camp and you have to make a fire during the night, okay, and yeah, you can see the flame. The flame is a kind of fluid because it composed of several molecules, right? So it can move easily in yes, a kind of gas, right? The gas is gas also belongs to the fluid. Okay, a flow of the river in a flood, for example, here in Kanchanaburi. If you have ever visited the Meklong Dam, okay, Meklong Dam, if you look at the water surface here, okay, it's a swirling, right? It's completely random, and I think there would be no equation to govern this effect, okay, except for you use the random theory, okay, the random behavior of the surface. Okay, that equation could tell you something, but you cannot predict the shape of the water swirling and so on easily. Okay, this is the realistic case. Okay, it's not the ideal case of the fluids. Okay, yeah, what we could do is to consider only the simple thing. Okay, I'm not sure whether in the future they may have a better content for the high school physics, okay? But for us right now, also in my generation, we can consider only ideal fluid during my high school, okay? And here swirling fire flame, okay? The flame of swirling fire, it's difficult to predict the shape of the flame. You can see here, right? And it moves or it changes also with time, the flame here. All right. So let's talk about our possible consideration of the fluid. An ideal fluid is a fluid that is incompressible. Okay. Let's say we cannot compress it and has a constant density. It's non-viscous. What is that? You have seen this, you have ever heard this word before, right? Viscosity, right? Viscosity is the friction between among several fluid layers, right? It's a kind of friction, actually. Yeah. Yeah, let's say the ideal fluid has no friction at all among several layers, okay? And yes, with this assumption, with these assumptions, we could go ahead. The ideal fluid has a steady motion, okay? No change of velocity. Sorry for that. ขอโทษครับ อยู่ดีก็ตามนะครับ okay. It has no change for velocity, okay? When they move, there is no velocity change. There is no density change. Okay, this is acceptable, okay, for us. Okay, we could realize that it's the density is quite constant. Okay, the pressure is the same. Okay, and the pressure remains constant at each point with time. Okay, it doesn't change with time, and it moves without turbulence. Okay, what you have seen here is the turbulence. Okay, sorry. The turbulence means the effect caused by the surrounding or the environment. Okay, if you have wind, strong wind can affect the shape of the flame. Okay, and that's the turbulence. That's the kind of turbulence. If you have a strong wind here, the water surface in any place could get swirling, right? And we cannot predict the shape or the direction of movement of that fluid anymore. Okay. Please know that wind can also have some effect to the fluid direction and fluid movement direction too, right? Yeah, but for us, it's too difficult if we get involved with so many effects. So for us in high school, we don't care about the turbulence at all. It has no angular velocity about its center. Okay, sometimes it can happen that anything could try to rotate itself, but we don't talk about the spin of the fluid at all. Okay, we may also treat a gas as incompressible. เลยเวลาแล้วครับ my god ใช่ปะเราเลิก10ป่ะ10นะครับโอเคไหมก็ต้องเบรกให้คุณเนาะเดี๋ยวคุณจะไปบอกผู้ปกครองเดี๋ยวเขามาตำหนิผมหาว่าสอนเกินเวลาโอเควันนี้ขึ้น ideal fluid ได้นิดหน่อยนะครับจบ we have completed we have finished the Boeing Force fluid pressure already so see you on next Wednesday, right? I just heard that the school has a policy to have the lecture, the class on site, right, at the school. So hopefully we would see each other on Wednesday at school if you want. But anyway, we can make negotiation if possible. If Dr. Chokslan can accept your deal and we don't need to pay attention so quite we don't pay attention seriously to the comment by your co-teacher because it's the agreement between you and me. And if Dr. Choksan say yes, you can also say if you want to have the class like this in online manner. Okay, if you don't want to go to the school, just let me know. Okay, ตกลงกันนะครับว่าคุณอยากเรียนที่โรงเรียนหรือไม่นะครับผมก็จะไปแต่ว่ามันก็จะขัดข้องนะเพราะว่าไม่ได้เสียเวลาเซตแล้วก็อินเทอร์เน็ตนะครับจะไม่แข็งแรงนะครับคุณคุยกันนะโอเคไหมครับอยู่7คนนะที่ช่องไอ้ Streamlabs นะครับโอเคไหมแล้วก็ไม่มีคนอื่นหรือมั้งที่ซูมก็ประมาณคนนึงนะครับโอเคไหมมีอยู่คนหนึ่งครับซึ่งคือชัยสิทธิ์นะครับก็คุณตกลงกันว่าคุณวันพุธหน้าคุณอยากเรียนที่โรงเรียนหรือว่าจะเป็นออนไลน์นั่งอยู่อย่างนี้เหมือนเดิมครับถ้าออนไลน์มันจะสมูทนะเพราะผมเซตอะไรไว้เรียบร้อยแล้วครับถ้าไปที่นู่นก็จะต้องเซตอะไรวุ่นวายอยู่ครับโอเคไหมจะเสียเวลาเริ่มเรียนนะครับแล้วก็แจ้งดร.โชคสลันว่าถ้าคุณต้องการแบบนี้ออนไลน์แบบนี้ดร.โชคสลันอนุญาตไหมนะครับโรงเรียนอนุญาตไหมครับเพราะว่าผมก็ต้องทำตามนโยบายของโรงเรียนนะเผื่อเขาต้องการให้คุณเข้าแถวประกาศฟังอันนู้นอันนี้ผมไม่รู้จริงจังหรือเปล่านะเพราะก่อนหน้านี้ก็ประกาศให้เรียนที่โรงเรียนแล้วสุดท้ายก็มาล่มกลายมาเป็นออนไลน์อย่างนี้เหมือนเดิมเอาคุณตกลงกันทั้งห้องนะครับแล้วคุณก็ถามดร.โชคสลันได้ผลเป็นอย่างไรคุณแจ้งผมโอเคไหมครับโอเคno let's talk about the homework right การบ้านก็คือ1ข้อนะครับเรื่อง Boeing Force นะครับคุณจะเอา partially submerged ก็ได้นะครับโอเคไหมจมนิดหนึ่งจมส่วนหนึ่งนะครับกันagain the homework is a problem about Boeing Force whether it's partially submerged or not okay that's matter or even simply low FVOG okay the Boeing Force in standard form โอเคบ๊ายบายครับสวัสดีครับ battery firstly. Oh, on. Yes, go on. And you have to forward the link like that. okay okay good morning everyone. Welcome you to I think everything is alright. Welcome you to SCI33206 เฮนรี่นะบอกว่าสัปดาห์หน้าออนไลน์ดร.โชคบอกแต่เขาส่งดร.โชคเพิ่งส่งข้อมูลมานะครับเขาเขียนบอกว่าเนี่ยเรียนอาจารย์วิทยากรตั้งแต่วันจันทร์ที่29พฤศจิกายนก็คือสัปดาห์หน้าหรือว่าเนาะสัปดาห์หน้าครับทางเรียนจะกลับมาดำเนินการเรียนการสอนโดยใช้ตารางออนไซต์นะครับเดี๋ยวผมแคปเจอร์หน้าจอให้คุณดูก็ได้ครับโอเคไหมคุณบอกว่าเขาให้เป็นออนไลน์นะครับก็อันนี้ของเมื่อคืนนี้นะผมก็ตกใจผมต้องแบกสัมภาระไปหาคุณนะครับเดี๋ยวคุณดูครับนี้ดูคุณดูนะ yes good morning everyone welcome you to SCI33206 Thanathon in Zoom only one person anyone more I have removed the คุณดูนะครับเนี่ย it's นี่นะครับโอเคไหมดร.โชคบอกเนี่ยครับเนี่ยครับดร.โชคบอกเขาว่าจะเป็นกลับมาดำเนินการเรียนการสอนตารางออนไซต์ยึดตารางออนไซต์นะคุณบอกว่าดร.โชคให้อะไรนะให้เป็นออนไลน์มันขัดกับที่คุณเฉพาะม.6 เหรอวันนี้เขาเขียนรวมๆครับเขาไม่ได้บอกว่ายกเว้นม.6 ผมเชื่อคุณนะเดี๋ยวไม่ใช่แบบโรงเรียนเขาให้คุณไปโรงเรียนแล้วแบบคุณไม่ไปแล้วคือคนสอนมันไม่ถูกออกจากโรงเรียนหรอกมันไม่โดนไล่ออกแต่คุณน่ะมันจะโดนโรงเรียนเขาไล่ออกหรือเปล่านะครับถ้าคุณไม่ไปโรงเรียนนะเอาตามที่คุณอยากได้แล้วกันครับโอเคwe follow what you want because this is my goal okay my purpose is to follow what you want because if you don't agree with that it's not good at all okay you will not be happy to do that right so I would prefer to follow what you want which is in an online manner of course in the on-site manner it might be complicated for me but I could do that already once last year okay with your elder colleagues your elder student classmate okay it's no problem yes right now we will talk about the นะครับผมส่งให้คุณไป3ช่องนะคุณเลือกดูเอานะถ้าใครจะเข้ามาซูมผมจะพยายามชำเลืองดูเรื่อยๆนะครับ alright so yes let's get to solid fluid right in 605/26 this one right it's your time okay we still have one remaining sub question in this example all right if you still can remember if you still can remember the remaining question from last Wednesday, from 2 days ago. ดีครับออนไลน์ครับผมขับรถเหนื่อยครับ ทั้งสอนคุณแล้วก็ขับรถกลับมาด้วยทั้งไปทั้งกลับรถอย่างติดเลยครับโรงเรียนคุณอยู่ใจกลางเลยโอเคyes 15 kilogram solid gold statue, right, is being lasered from the sunken treasure ship, right, in let's get back to that situation. Okay, this one. Okay, yes, from the tension in the here we have the tension in the hoisting cable, right? So we have already calculated the case when we hang it in the sea, right? And this one is still in the seawater, right? And right now, once we move it up and now the statue is out of the water, okay, it just stay above the water surface, okay, above the water surface now. So now, oh, I forget to wear the microphone here. Okay, positive and plus, right, the summation of F, but W is pointing in the opposite direction to the positive going up here. So we have negative for W, right? So it's equal to 0, and yes, we they want to know T2, so T2 will be W, right? And W is mg, right? Mass of what? Mass of the mass of statue, right? Mass of statue, so we have right here mass and mass of statue 15 kilogram, right? 15 kilogram and 9.8, right? So we could go to the calculator. T2 starts, right? So it's T2, right? T2 is mass of statue, right? Mass of statue times G, right? So we have that, and we're gonna keep mass of statue is 15 kilogram, right? And G is the ทุกคนเห็นครับ G is the gravitational on Earth, right? It's on our planet 9.8, or you also can use 9.81 or number 10. Okay, it's up to you. It doesn't matter for me. And yeah, M said times G. Okay, it's our oh what happened เกมมาครับขออภัยด้วยครับคนยูซูมเสียงหนวกหูแน่นอน alright, let's compute it. T2 is 147. Okay, T2 is 147. อยู่ดีเกมมาตกใจเลยนะผมไม่ได้จ่ายเงินเขาคือมันเป็นแอปฟรีนะครับถ้าจะเอาโฆษณาออกต้องจ่ายเงินครับ Newton. Okay, and yes, like this, and we have finished the second sub question to this problem, right? Okay, yes, we have completed this problem right here, right? And now we move to the next thing. Okay, the next story. You have already seeing the Boeing Force, right? The lifting force caused by fluid. All right. The lifting force caused by fluid in general case, right? That's the submerging condition, right? When the density of the material is greater than the material greater than the density of the fluid, okay, it's gonna be sunken, right? The material just stay at the bottom of the container, like the sea water or in the glass ใครจะเข้าอีกไหมครับมีธนกรอยู่คนเดียวนะธนกรกลิ่นธรรมผมพยายามดูที่ซูมนะครับซูมผมปลดพาสเวิร์ดออกให้แล้วนะค่อยๆศึกษานะครับผมก็ใช้ไม่ค่อยเก่งครับค่อยๆศึกษาแล้วพบว่ามันไม่ต้องใช้พาสเวิร์ดก็ได้ด้วยนะครับแล้วก็จะผมไม่กล้าปลดแบบว่าไม่ต้องอนุญาตเลยนะครับกลัวแบบอยู่ดีๆเดี๋ยวมีฝรั่งแทรกเข้ามาห้องเรียนเราแล้วแบบรบกวนคุณนะครับผมก็ไม่กล้าทำนะคือถ้ามันฟรีเกินไปมันก็ความปลอดภัยมันก็จะลดลงนะครับดังนั้นผมก็จึงไม่กล้าทำนะครับโอเคไหมเดี๋ยวมันที่เคยเห็นนะครับคุณเจอนอกเทอมที่แล้วนะครับมันมีคนแอบแทรกเข้ามาซึ่งไม่เกี่ยวกับเรานะครับแอบแทรกเข้ามาที่ห้องเรียนนะครับระหว่างนั้นนะครับก็เนอะไม่ดีกว่าเนาะหรือว่าถ้าคุณต้องการแบบนั้นโอเคครับโอเคnow yeah we have considered few example about the object that's immersed, okay, fully immersed into the water, right? Yes, now we move to the next scenario when the object is not fully immersed, okay, it's partially submerged. It means it's floating, okay, the object is floating, it's not sunken into the bottom of that container. Okay, let's talk about the next scenario. Okay, this scenario will happen when the density of the material or of this object is less than the density of the fluid. Okay, if the fluid is more dense than the material, we're gonna have a floating scenario like this. Okay, we're gonna get the floating object. Okay, if you throw anything into the water, if you look at the water and you see something floating, it means that the density of that object is less than the density of the water. Alright, ปาฏิหาริย์นะครับขออภัยด้วยนะครับเพิ่งเห็นนะครับแจ้งในไลน์ได้เลยนะถ้าใครรอแล้วไม่เห็นผมปลดให้เข้านะครับเพราะว่ามันไม่เตือนนะครับผมต้องใช้อีกเครื่องนึงสังเกตครับค่อยๆดูเรื่อยๆครับ Okay, yes, we arrive at the second case of Boeing Force, right? It's floating scenario, okay? The material or the object just stay at the same level as the liquid surface, right? Like this, okay? But it's a part of the volume of this object is under the liquid surface, so it gets into the water a little bit, okay? And parts of it is above the water surface, okay? and this scenario is called partially submerged scenario. Okay, and yes, as you know, in the hoisting example here, hoisting cable example, you have an external force. Okay, that's the force caused by the tension of the cable, right? You have an additional force by human, by machine, or by anything. Okay, that's the external force. But let's take a look at this scenario. In this case, the object just stay without any helping force. Okay, there is no hoisting cable or any string or rope, okay, to pull it up. Okay, this one just stay by itself. Okay, this can happen due to the less density than the density by the fluid. Okay, and yes, let's go further. Yeah, if you draw the free body diagram, that like the figure 56, you could see that there are only two forces. The first one pointing downward is the weight of this material, and there is also the force pointing upward, right? And it's the force caused by Boeing Force, right? It's caused by the molecule of the liquid that tries to move this object up, right? Yeah, the Boeing Force depends on the density of the fluid, depends on the volume of this material that is submerged into the water. It depends on the gravitational acceleration on that planet, whether you are in Mars, in the sun, in the moon, or on Earth, like this. Okay, now we will get into the detail of this equilibrium state by Newton's first law. Sigma F remains 0. We get okay, let's talk first about the Boeing force here. Boeing force, of course, the absolute value of Boeing force is rho F, right? The density of the fluid, V of that object, and the gravitational acceleration on Earth. Let's talk about that. Rho F is, of course, the rho of fluid. It's fluid density. Fluid density นะครับการบ้านวันนี้ครับเรื่องBoeing Force นะจะเป็นแบบจมก็ได้นะครับหรือว่าแบบลอยอย่างนี้ก็ได้นะเอาห้องสุดไปแล้วนะครับเดี๋ยวผม create ให้ later. Okay, low F is like that, but VO, the volume of the object. In this case, that's the fully this is the formula for fully submerged case, right? Fully submerged case. Okay, but for the partially submerged case, VO is not the volume of the object. Okay, not the whole volume of this object at all, right? VO is gonna be partial submerged, partially submerged volume, right? And it's now noted by the letter V, but with the subscript PS. Okay, PS is not PlayStation. Okay, it's not PlayStation 10. PS stand for partially submerged. Okay, the situation when this material is floating on top of the water or on top of that liquid. Okay, PS means partially submerged. Okay, and then we go to the detail. Once we apply the Newton's first law, sigma F remains 0, and we have M Boeing Force and lower W, right? It's gonna be W be equal W. Okay, and yeah, that's the next outcome. Okay, we have on the left W, right? The mass, the weight of this object. This is mass, and there is G. Of course, W equals M times G. And let's get into the detailed mass of this object. The whole piece of this object is going to be, from what you have learned before, density equals mass by volume, right? For finding the mass, we have to move V to the left hand side. We are going to get density times the volume, like this, right? So the mass of the material or the object is going to be the density of the object times the volume of the whole piece of that object, right? So we get W as rho 0 VO, not rho 0, rho O VO and G. That's why we get the left hand side here, W weight of this object purely, whether in any situation. That's the basic thing. Okay, you can determine the weight from the density of that object and the volume of that object. Okay, and on the right hand side, Boeing Force now becomes low F, not VO anymore. Okay, as you have seen before, VO is no longer used in the partially submerged. VO is going to be VPS. Okay, it's going to be VPS, the partially submerged volume. So from low FVOG, it's going to be, it turns to be VPS. Okay, VPS, the volume of the partially submerged. It means in this case, you just determine the volume in this portion. Okay, but this is only the side view or the cross-sectional view of this object. It's three-dimensional system, so you have to multiply the depth of this material. You get the V partially submerged volume. Okay, the partially submerged volume, VPS. All right, on the right side, the Boeing Force now turns to be low F, VPS, and G, right? And you know, right, there is a common term G right here and 9.8. Whether you use 9.81, whether you use number 10, it's the same. Okay, you cancel G on both sides, and it's not so convenient, right? Sometimes they want to have the same kind of variables together, so the remaining thing is the product between density and volume, right? So it would be nice if we move the density to one side and volume to another side. So they move low F to the left hand side. They move VO, the volume of that object, to the right hand side as the denominator here. Now you get this formula: rho O, rho density of that object, divided by density of the fluid, and we partially submerged volume divided by VO. Okay, from this equation, as you see here, of course, VPS, the volume of partially submerged, is less than the volume of the object, right? The volume of the object is the whole piece here, the whole volume, but the volume of partially submerged is only the portion under the water surface or the liquid surface. So of course, the volume of partially submerged portion here is less than the volume of the whole piece of this material. So because the numerator is less than the denominator, it would hold also for the left hand side. In this case, we can make a deduction that low density of the object should be less than the density of the fluid. Okay, so you see any fluid, if you see any object that is floating on top of the water or any kind of liquid, it means that you can infer it. The density of that object is less than the density of the fluid. Okay, for example, if you use the foam, the white material ครูปิดไมค์อยู่ครับsorry for that ก็เปิดไมค์แล้วนี่ฮัลโหลครับปฏิหารครับได้ยินเสียงไหมเอ่ยเดี๋ยวผมเทสไมค์ที่ช่องซูมก่อนปฏิหารขอบคุณมากครับที่แจ้งครับเสียงผมเป็นไงได้ยินไหมเอ่ยอ่านหน่อยครับครูปิดไมค์อยู่ครับก็อ่านแล้วครับฮัลโหลเทสไม่ได้ยินเสียงเลยเทส 1 2 3 test 1 2 3 test 1ไปแล้วอยู่ดีๆเสียงมันก็หายแล้วห้อง604ตอนเริ่มต้นมันเวิร์กอยู่นะครับโอเคไหม sorry for that อ่านหน่อยครับขออภัยด้วยครับปาฏิหาริย์เพิ่งเห็นแล้วก็อ่านแล้วแก้ให้แล้วนะครับเสียงมาแล้วนะครับปาฏิหาริย์ที่ซูมนะครับส่วนพวกคนอื่นอยู่ที่ช่อง Streamlabs ใช่ไหมใช้โทรศัพท์ถ่ายหน้าจอ iPad ครับผมโอเคผมถอดหูฟังนะครับไม่งั้นมันจะกล้องอยู่อย่างเงี้ยนะมันจะเวียนหัวนะครับโอเคthank you very much ปาฏิหาริย์นะครับโอเคyes we go ahead พูดนานแล้วเลยอย่างปาฏิหาริย์30 นาทีหลายนาทีที่แล้วนะโอเคthe first example about partially submerged case is this one, right? Loft, okay. Loft นี่ชื่อเหมือนอดีตเพื่อนร่วมงานผมเลยนะ แต่ว่า Loft มันเป็น RALF นะครับโอเคไหมอันนี้มัน Loft ที่แปลว่าแพรเพื่ออะไรเนี่ยโอเค Loft is constructed of wood having a density of 600 kilogram per cubic meter. Okay, as I told you, the density of any object that can float above the water is should be less than, okay, is a must, okay, is less than the density of that fluid or that water all the time, okay, otherwise this equation would not hold. When this equation doesn't hold, the object would get fully immersed into the water. Okay, they would just go to straight. They would go straight to the bottom of the container. Okay, so but in this case it works. Okay, the density of the Loft, okay, which is supposed to be made of wood. Okay, I just know that some kind of wood is less dense than water. But if ผมไม่รู้ภาษาอังกฤษเรียกว่าอะไรถ้าไม้สักไม้อะไรอย่างเงี้ยมันน่าจะแน่นกว่าเนื้อน้ำปะน่าจะจมเนาะแต่ถ้าเป็นไม้เบาๆครับไม้เนื้ออ่อนอ่ะมันน่าจะลอยครับโอเคไหม so that's the case for us here in the second part of the Boeing Force, like the partially submerged scenario. A Loft is constructed of this wood with this density, and its surface area is 5.7 square meter. Yes, the volume is 0.6 cubic meter. The volume of the whole piece of this cubic is 0.6 cubic meter. It's not cubic, it's kind of rectangular because the sides in each dimension, the sizes in each dimension are not the same, okay, are not equal to each other. It's not cubic, but it's rectangular cubic or something like that. When the lava is placed in fresh water, as in figure 57, like this, okay, it just floats. But to the floating scenario here, they would like to know what depth H the bottom of the lava submerged. Okay, they would like to know how deep is the wood staying under the water surface. Okay, let's say there is no wave, no wind at all. Okay, the water surface is smooth, is planar. Okay, and yeah, we will see how to determine H. Okay, they would like to know H, the depth of the wood under the water. Okay, yes, of course, we have to apply the result of 87, right? Which is what we just learned recently, right? 87. So let's go with that. Just from 87, from equation 87, we have rho O, right? The density of the object divided by the density of the fluid equal to the volume of the partially submerged object and the volume of that the whole volume of that object, right? นะครับผมนะครับไม่มีปัญหาอะไรนะครับที่อื่นไม่มีปัญหาละเสียงไม่ดีภาพไม่ดีอะไรยังไงโปรดบอกนะครับโปรดบอกผมได้นะครับ okay, and then let's go ahead with that. Just we have H here, right? H like this, and yes, we have this relation from partially submerged scenario, and rho O is the density of the object, right? Then density of the object is the wood, right? Density of wood, right? In yeah, rho wood is what they have provided. Density is 600 kilogram per cubic meter, right? In rho F, they say fresh water, right? Then the fluid right here is water, right? Density of pure water, right? Fresh water seems like pure water, right? This is pure water, and yes, law of water is 1000. Okay, 1000 kilogram per cubic meter. Okay, you could see that the amount of density by water is greater than the density of wood. Okay, so in this case, the object can float, okay, above the fluid. And yeah, we have already seen everything on the left hand side. On the right hand side, VPS, right? VPS is the partially submerged volume. So the partially submerged volume is the volume under the water, right? VPS is gonna be, of course, it's a kind of rectangle, right? Rectangle shape. So it's gonna be A times H, right? And H is what they want, right? A is known, right? A is known, is what we know, and V object, the last one, the volume of the object, what is that? They said, do they provide information? Okay, the volume of the Loft here is 0.6. Okay, they say 0.6. Okay, cubic meter, right? So yes, we have got that, and we would substitute everything into this expression, right? First we go on the variable first, rho O and rho F. VPS is A and H, right? A and H divided by VO, right? And yes, you can solve this equation to H variable because this is the quantity we would like to know from this question, right? From this example, we want to know H in this scenario. So we solve this one for H. We would get rho O VO divided by rho F, density of fluid, and the area of the wood, right? So H will be density of the object, density of wood. So it's right here. We have already 600, right? 600 kilogram per cubic meter, and VO is the volume of that object, which is 0.6 cubic meter, and divided by density of the fluid, which is 1000, right? And the cross-sectional area, right, which is what they also provides 5.7, right? We move it, we substitute it into the calculator, right? Let's go to Madonna and source. Yes. What is that? ผมก็จำไม่ได้ใครจำได้บ้างเท่าไหร่นะH is 600, right, times 0.6, if I can remember properly. Yes, 1005.7. 1000 and 5.7, right? Okay, yes, that's the height. Okay, the height from this 63158 63158 meter. Okay, and that's the height. Okay, the height that's stay under the water. Okay, here the depth of the water under the water, and you can also see that it's around ผมถูกหรือเปล่า 006, right? ถูกลอกเลขมาผิด06 0 in front of that, so it's around 6.3, okay, centimeter. Okay, yeah, that's the depth of the wood under the water. ผมขออนุญาตเข้าห้องน้ำแป๊บนึงนะครับเดี๋ยวกลับมาครับ Okay, let's get back to our second problem in floating scenario. Okay, it's B equal to low F, V, P, S, and G, right? Now let's move to the next page about it's a complicated, okay, more complex problem. Here we have the cube. Okay, now the sides of everything, every dimension in 3 dimensions are the same, so it's a shape of cube. We have a cube of aluminum with the mass 1,000 kilogram. It's 1 ton. Okay, and it's placed in a tank. Okay, it's a big container, strong big container. It's called tank, and water is then added to the tank, and until half the cube is immersed. Okay, the water is poured into this tank, and until the half of the whole volume of this cube. Okay, and of course this one doesn't float. Okay, because it's very heavy, and of course it just stay on the bottom of this tank. And what is the normal force on the cube? Okay, they would like to know the normal force due to the ground, okay, caused by the bottom of this tank or container. And that's the first scenario. Okay, that's the first scenario. And the next or the second scenario is that later they slowly pour. Okay, they slowly pour the mercury. Okay, mercury is a kind of fluid, right? But mercury is quite different from other types of liquid, because mercury is a heavy liquid actually. What is the reason why I say heavy? Because the density of mercury is on the same order as that given by heavy metal. Okay, like what is that? The steel, iron, copper, gold, silver, those types of metal have a large number of densities, and mercury is in the same order as that one. Okay, it's not light as water. And yeah, mercury is slowly poured into this container, and they pour in such a way that they stop pouring once they found that the normal force here doesn't happen anymore. Okay, when they found or they detect that there is no more normal force caused by the bottom, the floor of this container, they stop pouring and they leave it like that. Okay, and in the second scenario here, they wanna know that how high is this mercury, what is the height of this mercury we should stop. Okay, we stop when there is no normal force. Okay, this one we still have normal force from the ground, and here we don't have the normal force by the ground, but we have a new lifting force, okay, caused by the Boeing Force of the mercury. Okay, and that's the first scenario and the second scenario. All right, let's go ahead with that. In the first scenario, they want to know what is normal force here, and in the second scenario, they want to know how high, which is h. Okay, and yeah, let's solve that. We go ahead. มีอะไรเสียอีกไหมครับผมขออภัยด้วยครับถ้าเกิด มีอะไรเสียนะครับวชิรวิทย์มานะตอนท้ายนะครับโอเคyes let's talk about scenario number 1 right situation 1 the first situation okay they pour water into this one right and yeah there will be lifting force caused by that fluid that water and there is because this one is heavy right there is reflection on the normal force caused by the ground or the bottom of this container pointing up right and there will be of course any object on the planet should have its own weight right so if you draw the free body diagram right it's mass m you have downward force caused by the weight you have the first lifting force caused by the buoyant force of water and you have another lifting force caused by the ground or the floor of that container that's the normal force okay and this is what we would like to know and let's consider the equilibrium state okay the static state equilibrium state right we could use the Newton first law right Newton first law Newton first law said that sigma f remains zero right so yeah if we use or we make the reference to the typical convention we say the positive y-axis going up will give us the positive quantity right so here we have b pointing up it's positive we have n pointing up it's also positive we have w pointing down right it's gonna be negative and yes on the right side it's zero right but they wanna know the normal vector which is the second variable in this equation equality we move b and w to the right hand side so n will be w minus b okay and let's get into the detail of each term okay w of what w of the weight caused by this aluminum piece or new aluminum cube so it's w m times c right and yeah m is the mass of this aluminum they say 1000 right they say 1000 times 9.8 right 9.8 and it's 9,800 Newton right here and Boeing Force is the one caused by water right it's gonna be because this is the fully submerged case it's not partially submerged case okay it's fully submerged case so we have it's partial too right but it's partial because the water level is not above the height of this cube it's partially submerged sorry for that okay b will be low f right low f and v volume of partially submerged right vps and g right the acceleration on earth on our planet all right so the next one is that we need to determine okay low f is simply known right low f is raw water right raw f is raw water it's 1000 right kilogram per cubic meter, right? Kilogram per cubic meter. And yes, that's the density, right? The first term is known, right? VPS is the partially submerged volume. VPS, they say they just pour the water until the water covers half the whole volume of this cube. So VPS is 1/2 of volume of the cube, aluminum cube. Okay, and do they also provide the cube? Do they provide do they say about the volume of this cube? No, nothing. So what could we do then? เราทำไงครับไม่บอกปริมาตรโอเคyes V cube, what is that? What is the value of V cube? They didn't provide. You know that V cube is the volume of the aluminum, right? Volume of aluminum. So from what you have learned before, the density rho is M by V, right? If you want to find V, the volume of the cube, volume of aluminum, right? So it's gonna be V cube. V cube will be mass of this cube or aluminum divided by rho, density of what? Because this material, this cube is made of aluminum, so we have to use aluminum, the density of aluminum, right? Even they don't provide the density of the aluminum, we have to get to any place, I don't know. This one, right? Okay. If you go to the table and look for the density of aluminum, right? Where is that? This is gas, solid, concrete, aluminum here. It's 2.7 times 10 to the 3, right? It's 2,700, right? In the aluminum, right? Aluminum is 2.7. Yeah, it's the same value. Okay, both books, both tables provide the same value. It's 2,700, right? So we go ahead with it. So the from the table, we know that low aluminum is 2,700. Oh no มีขนาดดื่มกาแฟแล้วนะมันยังเบลอนะครับโอเคไหมkilogram per cubic meter, right? You get that value, volume of the cube. And the next thing is it's time right now to determine VPS, right? VPS, partially submerged volume, is going to be half the volume of the cube, which is mass of the cube, and mass of the cube is 15 kilogram, right? Oh no, 1,000. Okay, let's leave it like that. Okay, we're gonna substitute later. VPS is okay, sorry. VPS is 1/2 of M cube by rho AL, right? Rho AL, and yeah, that's VPS. And what else? You know B right now, right? You know W, you know everything. It's time to compute N, the normal force, right? N will be W, which is M of aluminum, M of cube, times G, right? And that's the first term, W minus B. Minus B, B is the product of rho F, rho of water, and VPS is 1 by 2 M cube divided by rho AL, right? In G, okay, you can see that we have a common term, right? We have a common term MQ and G. So let's move out of the parentheses. We get M cube times G, and open parentheses we have something here 1 minus 1 1 is minus 1 by 2 of M. No, there is no longer M cube is rho water and rho aluminum. Okay, rho of aluminum. Now it's time to move substitute everything into this expression. M cube is 1000 times C, which is 9.8, and then 1 minus 1 by 2. Rho of water is 1000. Rho of aluminum is, what is that, 2.7 is 2700 kilogram per cubic meter, and you have here 9800, right? 9800, and yes, it's 5400 minus 1000, okay, divided by 5477, like that. And please don't remember, don't forget, we have, right? Okay, we don't forget, we didn't forget G, not right, it's right there, right? So if you use your hand, right, it's gonna be, if you use your hand, it's gonna be 9, 8, and 54, right? And it's here 4400, okay? 9, 8, 55, 54. And let's use the calculator. ขออนุญาตคำนวณที่อื่นครับเพื่อว่าสลับหน้าไปมาแล้วมันยังงงครับใช้คอมพิวเตอร์นะครับอาจจะไม่อยู่ในจอนะครับแต่ถ้าใครอยู่ที่อีกช่องหนึ่งครับก็อาจจะเจอจะเห็นว่าผมคำนวณไง98ครับ oh it's 98 divided by 54 times 4400. Okay, yeah, it's 7985. It's equal to 7985.1845919. Okay, up to you. And yes, it's in Newton, right? Because this is the normal force. It's a kind of force, right? It's not M. This is N. Normal force is like this. That's the first answer to the first sub question. Let's talk about the second scenario, the situation number 2. Okay, the second scenario, the second situation. Let's talk about the second situation. What is that? So they pour the mercury, right, into the water in until there is no normal force at all, and it's still stay in equilibrium state. There is no lifting force caused by the ground or the bottom of the container, but rather we have instead the lifting force caused by the mercury, right? We use the Boeing Force by the Boeing Force caused by mercury to lift this one up, and they just pour the mercury until we don't detect or find the normal force anymore. So if you draw the free body diagram of this object, of course, you would have the first layer of water, right? First layer, and you have another layer of something toxic, mercury. Okay, this is mercury, and let's say this is H2O, right? This is Hg, right? And here is the ground, the floor of the container. Okay, got the floor. Okay, let's draw the free body diagram. Of course, we have weight, right? W mg, right? We have lifting force caused by the first liquid, which is H2O, right? B H2O, B water, and we have another pointing up to, right? The lifting force caused by mercury, right? Hg, right? And yeah, it's again stay in equilibrium state. Equilibrium status, and we can use the Newton's first law the same way, right? Newton's first law, and the result is sigma f equals 0. All right, sigma f equals 0, and we use the typical convention, right? And yeah, past and so on, right? You follow this, and you would find at the end that the normal force Bhg. Okay, you form up this equation and you compare it to the previous scenario. Bhg is going to be normal, equal to normal force. It would be equal to the normal force as same as before, right? But let's get into the detail of the lifting force, the Boeing force caused by mercury. So what they want to know is the height here. The height here caused of the layer of mercury, right? Hg. What is this value? Okay. If we go into the detail, Bhg is the low F, right? Low of liquid, low of Hg, time V, right? V partially submerged, and times C, right? Times C. So we need to determine. Okay. Rho Hg is available from the table. We could find it easily. It's not a big deal, right? But we would rather pay attention to VPS, partially submerged. Okay, partially submerged means the volume of this object inside the liquid. Okay, that portion. So the mercury will be the object will be surrounded by this mercury by H, right? The height H, and volume is the product of the cross-sectional area times H of Hg, right? And they say that the aluminum here has the shape of cube, right? It has a cubic shape. So I don't know, VPS is like this right now. อมันล้าก็ลืมนะครับลืมจากสอน604อย่างเนียนเดียวVPS is like this AHG and A is not VPS it's like that AHG they wanna know H right so we substitute we didn't know yet the cross sectional area okay area of the cube and what is that okay, area of the cube let's talk about the shape of the cube any cubic shape is somehow like this right you would have this one here x okay we don't know the size of this cube yet this is one here x and we also have the height as x right and the volume of the aluminum of the cube will be x let's just to the 3 right with the power of 3 so we know v cube but we don't know a cube right and of course if you take a look at a cube here a cube is the product between the width and the length right width and length is x square okay x square is like that but what is that VQ we would like to know VQ right we want to know VQ AQ is x square and VQ is x with the power of 3 so what is the relation between AQ and V cube and of course you would find that A cube is the is x3 with the power of 2 by 3 right you just place it again by the power of 2 by 3 you get x square like this okay it's the area of the cube but what is x with the power of 3 x this is 2 3 that's the V cube right so A cube is V cube with the power of 2 by 3 okay and do we know V cube in this scenario do we know the volume of the cube in this scenario they didn't provide the information of the cube volume at all right they didn't say something like that they just say they have 1,000 kilogram of the aluminum right so V cube so let's go further we are now trying to find V cube what is that but as you know before right density is rho of that object divided by equal mass of that object divided by its volume right if you want to find VQ you move V to the left hand side move low to the right hand side VQ will be M right M mass of what the mass of this aluminum right mass of this object which is 1,000 mass of aluminum divided by density of aluminum too right mass of aluminum is 1,000 kilogram divided by density of aluminum any of you who knows density of aluminum let's get to the density table we have two tables of density where is aluminum is right here it's 2,700 right as we have seen before so this one is 2,700 it's actually 10 by 27 or approximately 10 by 27 0.41 666 blah 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 okay cubic meter. All right, but it's not our target. We want to know. Oh, no. We want to know a cube, right? So a cube, the cross-sectional area of the cube here, it will be 10 by 27 with a power of 2 by 3, and we would get that right from the calculator again. Oh no, it's not. I'm wrong. It's 73 here. 0.73. 73. Oh, 37. I'm stupid. 0.37. Yeah, it's already correct. Yes. And if you put it into the calculator for this one, right? This expression, you put it into the calculator, you get 10 by 27 with a power of 2 by 3. ภาษาไทยมาได้ This is 2 by 3. Yes, it's 0.5157. ปากกา 0.17. Approximation too, right? 0.5157 and oh no, why do we have that? And 3, 2, and it's square meter, right? The area unit is square meter. We get a cube right now, right? This is a cube. VPS is known, right? Let's get back to this expression. HG is equal to, is the same amount of the normal force. We know rho HG, right? It's 2,700. VPS is the product between a cube and HG, with the height of the mercury. Height of the mercury here, okay. Height of the mercury, and yeah, we would be able right now. N, right? N on the left is rho HG, and V, right? VPS is the volume, and it's equal to a cube, and H, the height of the second liquid HG, right, mercury, and G at the end, right? Now you're gonna need to solve these equation for the destination, the variable, the HG, right? The height of the mercury, HG is N, rho HG, and A cube, and G, right? So you get the normal force from the previous sub question 7985.18. 7985.1819, okay, approximation. And rho HG is 2,700, and AQ is what we have just got before recently, 0.51, right? 0.516, and G is 9.8, right? And we will be able to solve that to get the height of the mercury, the second fluid, in. Right, where is October? October N is like that, right? It is this value in. No, density of what? Density of the density of mercury. Okay, mercury has the density greater than aluminum. It's not 27, it's 13 times 13 times 10 to the 3. Okay, 13.6. I'm sorry for that, missing one decimal precision. 13.6. Yeah, and A cube is 0.5157 or 516. Okay, in J is 9.8. You get height, the depth, the thickness of the mercury layer as 0.011617 meter, right? And in appropriate units, if it's difficult to understand, it's actually equal to 1.2 centimeter approximation. Okay, approximately we get the solution like that. Okay, the answer to the second sub question, like 1.2 centimeter. All right, we need to quit the lecture right now, right? Because we have to stop at 11:50. It's 11:32 right now. จริงๆห้อง64เขาขึ้นพวก ideal fluid ไปแล้วแต่ว่าขึ้นหน่อยแล้วกันนะครับ โอเค yes in the next topic we have finished the story about fluid pressure and Boeing Force. Okay, Boeing Force in the first scenario fully immersed into the liquid, and the second case partially submerged into the liquid, right? So the next topic, okay, is ideal fluid. We're gonna go further and further to ideal fluid, and then continuity equation, and then Bernoulli equation. Okay, how the fluid move. Okay, you have seen already the fluid staying in a constant way. Okay, the next one is the dynamic, the movement of the fluid. It's a little bit more complicated, but it's not beyond your ability. Okay, here now the fluid is moving, and if you have a visit at any dam, okay, not only in Kanchanaburi, this dam is called Maeklong Dam. Okay, and if you take a look at the water surface, it's hardly it's hardly predictable. Okay, you cannot simply predict the surface of the shape of the water surface here, okay, because it involves so many factors, the flow from different parts in this water gates, right? So yeah, in the realistic case, the behavior of the fluid is very complicated. So we cannot get into the detail. Okay, it's beyond human ability right now at the moment. Okay, maybe in 200 years later, I have passed away or I'm died already. Yeah, here is the whirling, is the flame. Okay, with swirling shape. Okay, it depends on many things: the pressure, the wind in that environment. Okay, this is the realistic shape of the fluid. Okay, why do you say this is the fluid? Because the flame is a kind of burning gas, right? And gas belongs to fluid. Okay, fluid and liquid are known as fluid, right? So in the realistic case of the fluid movement, we cannot predict the shape at all. It's very, very hard to predict the shape of the movement of that fluid. Okay, we are gonna consider ideal fluids. Okay, we will talk about that on Wednesday, and I hope that we could see each other in the online manner, right? You think we can meet on Wednesday in the online manner นะครับคือวันพุธเรียนที่แบบออนไลน์ได้จริงหรือเปล่าคุณถามดร.โชคนะครับเฮนรี่พัสสิกช่วยถามดร.โชคหรือว่าใครก็ได้นะที่เป็นตัวแทนถามว่าเพราะว่าเขามีจดหมายมาผมส่งให้คุณดูแล้วนะว่าเขาบอกห้อง6ออนไลน์จริงม6ออนไลน์จริงก็เป็นงั้นได้ก็ดีนะเดี๋ยวผมเช็คกับดร.โชคอีกทีนะครับเพราะว่านโยบายโรงเรียนมาเขาไม่ได้พูดยกไม่ว่าไงก็ตามก็Okay, let's talk about our homework. Okay, the homework is something about, of course, what we have just finished. The Boeing Force. Okay, the lifting force caused by the fluid. Okay, the material is immersed into the liquid or the fluid, right? And yes, we're gonna see it into cases, right? Fully submerged and partially submitted. Okay, choose any scenario that you could do. Okay, and make the high precision in computation. Okay, because I use computer. And นะครับการบ้านก็คือให้เลือกปัญหานะครับของการเอาวัตถุจุ่มลงในของเหลวนะครับในน้ำหรืออะไรก็ได้เป็นชนิดใดก็ได้ที่เป็นของเหลวนะครับแล้วก็ให้หาเรื่องที่มันเกี่ยวกับแรงลอยตัวนะครับก็คือ Boeing Force นะ lifting force นั่นเองนะครับ1ข้อเหมือนเดิมนะครับส่งวันศุกร์หน้าเดี๋ยวผม create นะครับใครไม่ได้พิมพ์ชื่อปลดพิมพ์ชื่อเดี๋ยวผม capture หน้าจอส่งให้พบกันใครส่งการบ้านเกิน9โมงมันจะขึ้นเลยนะครับคุณได้สิทธิ์ 0.75 นะครับถ้าผิดก็ 0.5 นะครับโอเคไหมเพราะว่าสติ๊กหน่อยแล้วกันเทอมที่แล้วปล่อยเกรดอย่างรู้เลยนะครับคะแนนง่ายมากโอเค see you on next Wednesday right บ๊ายบายครับสวัสดีครับ if you have any question just let me know raise your hand but not many of you are in the class right now okay I don't know what you are doing only 3 people in the YouTube channel 1 person ปฏิหารนะครับ in the Zoom channel right บ๊ายบายครับสวัสดีครับ 3 and these one too and this one too rightกดจะพบเลยนะกดจะพบไปแล้วนะก็yes sir this one the second monitor oh no M605 right yes and then we stop the okay converter and okay we stop the OBS right OBS looks fine in okay and this one we stop right stop our stream in yes okay and oh this one too right finish.